Welcome back. Okay, we're looking at our third example, tan theta equals 1.37. So we're interested where tan is going to equal this. Remember that we are on a restricted domain from the original question. We know that theta, we're only interested in answers between 0 and 360 degrees. Now, if you know what tan looks like, we can do a little bit of investigation. We certainly don't have to. This investigation would not have to be done at all. Let's leave the investigation alone. Let's just do this straight up. Step 1. Use calculator. So, using my calculator, I do tan inverse 1.37. And I'm going to get 1.37, second function tan, 54 degrees. So therefore, theta equals 54 degrees. Excellent. Step 2. Notice I didn't have to change 54. 54 is a principal angle. It's between 0 and 360, and it's positive. So step 2, use Castro. C-A-S-T. What are we looking for? I'm looking for where tan is positive. Now my first answer is in the first quadrant. 54 degrees. That is my related acute angle. Now my related acute angle can go in this quadrant, or this quadrant. Well, I want tan to be positive, so I'm going to put it in this quadrant. So it comes down here. So my related acute angle has to be in this quadrant somewhere. Now we know that related acute angles are always measured from the horizontal, so it needs to come here. So that is going to be 54 degrees. That's wonderful. But what I want is the rotational angle it takes me to get there. So starting at the initial arm, 90, 180, plus 54. So my new answer is going to be theta equals 180 plus 54. So it's going to be 234 degrees. So we have two answers. Therefore, tan 54 is going to equal approximately 1.37, and tan of 234 is going to equal approximately 1.37. Let's just check. 234 tan, and it does. That's it. And so that was without the investigation. If I did the investigation that I was about to show you, what I was going to suggest was, if you know what tan looks like, we know that tan has a vertical asymptote at 90. It has another one 180 degrees down the road. So 180 degrees down the road is going to be 270. How do I do that so fast? I take 180 and I add 90 to it, so that's 270. Okay. This comes across. And so I know that tan looks something like this. Nope. Here you go. Not that one. That was wrong. And so there. So the question, where is the range value going to equal 1.37? You're going to have one answer here in quadrant 1, and you're going to have another answer way over here in whatever quadrant that is. Well, that's 90. That's going to be 180. That's going to be 360. Your quadrants are quadrant 1, quadrant 2, quadrant 3, and quadrant 4. There's your investigation. And certainly we didn't need the investigation at all to see how this is working. All right, last one. Determine, now look, we have a restricted domain. Theta is between 90 and 180. So, and it's going to be cosine, and cosine's negative. So, let's not worry about an investigation thinking about it. Let's just use our process. So, step 1, use calc. So we're going to use cos inverse negative 0.58, and that's going to give us 0.58 negative, second function, cos 125. Okay, so that's your first answer. Step 2. Where else is cosine going to be positive? So we're going to use cast C A S T. So we know that the other place where my first answer is 125. Oh, not positive. It's where else is cosine going to be negative. So my first answer is here. That's 125 to get there. Okay, so what's the related acute angle for that triangle? Well, it'll be 180 minus 125. So that's going to be 55 degrees as a related acute angle. Where else is cosine negative? Cosine's negative here. So where would that related acute angle go? Right here, measured down from the horizontal, so that would be 55. Remember, that's 180. So the rotational angle to go all the way around there is going to be 180 plus 55. And that's 235. So I've got two answers here. I've got theta equals 125, and I've got theta equals 235. But we had a restricted domain. I'm only allowed to take values between 90 and 180. So the only value that we can use is this one. So what we say is omit not on the given domain. Or you can call it a restricted, meaning certain values are not allowed. Restricted domain. Okay, kids, work on those. That should be good. Your homework is on the next sheet. It looks like this. And I would like you to go through this entire sheet and do every other part so that we can talk about it on Monday, and then I can assign the other half of it. Okay, so 1 to 7, every other part, and there's answers on the back. When I say every other part, I mean A, C, E, A, C, E, G. Yeah, you get the idea. Okay, have a good weekend. We'll see you Monday.